Hello everyone, the Teen Engineer here, and today we're going to tackle another linear momentum problem. So let's read it. A particle of mass m1 equal to 2.8 kilos moving along the x-axis collides with a particle of mass m2 equal to 4.8 kilos initially at rest. The incoming particle is deflected in the direction 22 degrees above the x-axis, whereas the target particle moves off at 10 meters per second at 35 degrees below the x-axis. What are the initial and final speeds of the 2.8 kilo particle? So let's look. Let me just draw it real quick. So this is before. So we have here, let's say this is M2, and then we have M1. We don't really know how fast it's going. So we don't really know. And then this is after. This is, let's just, so the incoming particle, so that's M1, the incoming particle. So after, let's just draw for M1 first. 22 degrees above the x-axis. That's the velocity, final velocity. 22 degrees above the x-axis. Whereas the target particle moves off at 10 meters per second at 35 degrees below the x-axis. So after, again, this is M2. So 10 meters per second, 35 degrees below the x-axis. 10 meters per second. Now, we have to use conservation of linear momentum. So let me just bring that here. So initial momentum is equal to final momentum. Now I'm going to use unit vectors, and if we have too many variables, then we're going to have to split the momentum into x and y, which is fine as well. So initial momentum, well, let me just 2.8 and 4.8. So m1 equal to 2.8. Let me just draw here. 2.8 and kg, and m2 is equal to 4.8 kg. Right? So at the beginning, it was just m1 that was moving, so the initial velocity is just 2.8. Well, the initial momentum is just 2.8 kilos times, and then we don't really know, so we just put initial velocity here. And then final momentum is, well, 2.8 times, well, now we have final velocity, right? We have final velocity of m1, that's for m1. And then we have to add it to also m2. So m2 is 4.8 times, and that's 10 meters per second. Now, the problem is we have two variables, which means we're going to need to separate this into x and y. So let's do that. So pix. So linear momentum in x is equal to linear momentum in y. So here it would be 2.8 kilos times vi is going to be equal to 2.8 kilo times, and then here we're going to have to separate it into, since this will be VF, and then we have to take the x only, so that will be cosine 22. That would be VF cosine 22, and that would be VF of, yeah, that would be good. And then we can do plus 4.8 times 10 cos 35. Now let's simplify this. 2.8 times VI is equal to 2.8. I'm just going to multiply that by cosine 22. 2.6. 2.6. We're going to give that times VF plus 4.8 times 10 cosine 35. It's just 39.32. Now let's do for the y2. So y, it's basically the same thing, pfy, which is since they said it was going in along the x-axis, so there is no linear momentum in y at the beginning. So 0, and then it will be equal to the m1 will be 2.8 times vf sine 22 plus 4.8 times 10 sine, actually it's minus, that will be minus sine 35, since we can see it's in the fourth quadrant, so the y should be negative. So let's simplify all that. (2.8 sine 22). That would be 1.05 VF, and the other one will be minus 4.8 times 10 sine 35 minus 27.53, and then we can just take that to the other side and divide that by 1.05, and VF be equal to 26.22 meters per second. And that was the final speed. So now we can also find the initial speed by just plugging back. So we can just find this equation here and just plug it back in. So here we can just erase that, since we know it's 26.22 times 26.22, and then let's do that. 2.6 times 26.22 plus 39.32, divide that by 2.8, and that should be 38.39. So the initial speed was 38.39 meters per second, and the final speed was 26.22. So that's pretty much it. Thank you for watching, and if you want more videos like this, then subscribe and like.